Let's learn the introduction to artificial intelligence today. Hey, welcome back to Artificial Intelligence Introduction class. In today's video, we'll know about the introduction to Knowledge Map. Here we divided the content into 4 parts. Let's move on to the first. Now let's see the definition of Knowledge Map. A knowledge graph is always a way of organizing information using a network of connected nodes. It's like a big web of knowledge that computers can use to understand and make connections between different pieces of information. A knowledge graph has 3 main parts: entities, attributes, and relationships. Entities are things like people, places, and organizations. Attributes are characteristics of features of those entities, like person's name or person's location. Relationships are connections between entities, like family relationships or geographic proximities. The goal of Knowledge Graph is to help computers understand and reason about information in a way that's similar to how humans do it. It's using fields like natural language processing, search engine, machine learning, and artificial intelligence to provide more intelligent and personalized service. Now, let's move on to the development of Knowledge Map. The history of Knowledge Graph can be divided into 3 stages. The first stage was early manual knowledge graphs. These are created and maintained by people, and were mainly using expert systems and artificial intelligence field, such as CLIC knowledge base and WordNet vocabulary library. The second stage was ontology-based knowledge graph. This knowledge graph used ontology as a way to express knowledge using a unified set of terms and concepts to describe entities and relationships in the real world, such as Yago and DBpedia. The third stage was graph neural network-based knowledge graphs. These knowledge graphs used deep learning techniques to present knowledge as large-scale graph neural network, learning semantic embedding vectors to infer and apply knowledge, such as Google Knowledge Graph and Facebook Open Graph. These 3 stages represent the evolutions of knowledge graphs, from manual creations to the application of ontology and deep learning, continually advancing towards more intelligent, automated, and scalable solutions. And then let's look at the types of knowledge graphs. Here are 4 types of knowledge that can be represented in knowledge graph. Fact-based knowledge graph is a type of knowledge graph mainly contains relationships, attributes between different entities, such as people, places, and organizations. Examples include Google's Knowledge Graph and Baidu Baike. Concept-based knowledge graph. This type of knowledge graph mainly contains relationships and attributes between different types of concepts, such as academic fields, domain concepts, and category relationships. Examples include DBpedia and Phrasebase. Lexical knowledge graph is a type of knowledge graph mainly contains relationships and attributes between words, such as synonyms, antonyms, and word roots. Examples include WordNet. Common sense knowledge graph is a type of knowledge graph mainly contains common knowledge about everyday life, such as common objects, habits, and rules. Examples include ConceptNet and CLIC. These different types of knowledge graph can help computers understand and apply different types of knowledge, providing more accurate, efficient, and intelligent support for fields such as AI and NLP. And finally, let me explain why knowledge graph is so important. Knowledge graph is important because it helps computers understand and apply knowledge more intelligently, making it more efficient and handling information and tasks. Here are a few reasons why it's so important. First, it improves accuracies and efficiencies in NLP. Knowledge graphs provides rich context information for NLP and helping computers to better understand and translate natural language text. Second, it supports intelligent question answering and semantic search, and it helps computers answer users' questions through semantic analysis and related inferences, enabling more intelligent question answering and search functionality. Third, it can enhance the effectiveness of recommendation systems and personalized services. Knowledge graphs provide more accurate and comprehensive user profile and interest models, which can improve the effectiveness of a recommendation system and personalized services. Fourth, it promotes cross-domain knowledge fusion and innovation. Knowledge graphs can structure and integrate knowledge from different fields, helping people to discover and utilize the links and interactions between different domains, and thus promoting cross-domain knowledge fusion and innovation. In summary, knowledge graphs plays an important role in the development of artificial intelligence and intelligent technology, with applications in natural language processing, recommendation systems, and more. In the next session, we'll move on to the composition of knowledge graphs. So that is what we need to learn today's class.